we have seen how a regular expression is useful in syntax analysis. The entire language has to be expressed so that lexemes can be categorized as tokens. Here, the emphasis will be only on how the sentence is formed and what are all the keywords and what are all the other requirements of a sentence in the language. For this, a regular expression is used to describe a language. Regular expressions are helpful in pattern matching exercises also. The concept of regular expression was formalized by an American mathematician called Sir Stephen Kleene. And when we form a regular expression, it is just a series of characters. These series of characters represents a search pattern. This search pattern can be used to categorize a token as to categorize lexeme as a instance of a token. The lexemes extracted will be weighed against a pattern, and if it satisfies the pattern for say a keyword, we'll say that identified textual part is a lexeme or an identifier. It is a convenient notation useful for representing tokens, and this is used in lexical analyzers. Now, what are all the expressions on regular expressions? How we can form different operators and how an expression can be formed. First one is Boolean OR. Boolean OR is represented by a vertical bar like this. Example is gray or gray. That means that both these words are valid in this expression. So if a given string matches with any of these two, it will be a successful pattern matching exercise. Parenthesis is used for grouping. Now, when we group, we will say an area where an operator has a precedence. So it defines the scope and precedence of an operator. Whatever given in parenthesis, it will be gained higher precedence, and it also helps to define the scope of the operands to be applied for an operator. See here, gray. Here we mean that after gr we have two alternatives. After gr it can be either a or e followed by y. This is the pattern to be matched. Now in quantification is used to specify how often a preceding element is allowed to occur. What do you mean by preceding element? If we say question mark, it indicates that 0 or more occurrences of the preceding element. Element that precedes question mark. See here color. Here question mark precedes. Here question mark precedes an element. Now this element can be either 1 or 0. Hence, we have color or color. Both are valid. The preceding element to question mark is U. So 0 or more occurrence of U. That's indicated by this quantifier called question mark. Hence, color CLOU question mark R represents 0 occurrence of U or 1 occurrence of U. Next is star. Star indicates 0 or more occurrence of the preceding element or the element that precedes to star. See A, B star C. Here star precedes B. Preceding element of star is B. So we will say that there can be 0 or more occurrence of B. Hence AB, ABC. Here B occurs once. Then comes AC. In AC, B doesn't occur at all. Take A. A is also valid because there is 0 occurrence of B. Then comes AB, ABC. More occurrences of B. Similarly, A, B, B, C. Last operator is plus. Plus indicates 1 or more occurrences of the element that precedes to this operator called plus. AB plus C. The AB plus C indicates 1 or more occurrences of B. Hence ABC, ABBC, ABBBC. 1 or more occurrences of B. Whereas AC is not valid because B is not at all visible here. Hence we can see that a regular expression is very powerful, and whatever search pattern we can express in natural language, using these operators we can form that expression as a regular expression or RE. For example, let us take a C language identifier. We know that an identifier, it can be a variable name, it can be a label, it can be the name of a function. So all these come under identifiers. An identifier, as per the C specification, the first name should be the first character should be a letter. Then there can be letters or digits. We have placed a star here because star indicates the presence of 1, 0 or more occurrences of preceding character. So see here, 0 or more occurrence of further letters or digits. Hence I is a valid identifier as per this RE regular expression. I is also valid. I1 is also valid. Now we can see that every regular expression has a language. Let us take the preceding examples. Here we have A, B star C. We can see that there are a lot of strings that match this regular expression. So we can see that A, B star C is a regular expression, and the strings that can be formed out of this expression is the language derived from that regular expression. And that's what it is specified here. If there is a regular expression called R, there is a language called LR which is formed out of as per this expression. Now this language can be represented recursively with the help of smaller sub-expressions. Now these are the sub-expressions. If epsilon is a regular expression, then language of epsilon is epsilon itself. Suppose that if A is a symbol in a language, then A is a regular expression. That means language of L is equal to A. Now, these are all the rules which can be applied to form larger regular expressions from smaller ones. Especially when we want to express the statements and complex expressions in a programming language, we will have to combine many expressions. Suppose that R and S are REs, regular expressions, and naturally there will be language represented by R and S. Let LR is the language represented by R, and S is the language represented by S. First thing is this OR operator, R or S. This is a regular expression. Since R is a regular expression, S is a regular expression, and OR is an operator used to form a regular expression, the entire thing becomes a regular expression now. Now, what's a language represented by this R bar S? R or S? It is language of R union language of S. It's an OR operation. Now here R S, regular expression R is followed by regular expression of S. It forms a different RE now. It denotes a language of LR followed by L of S. R star, a quantifier is applied to the entire regular expression. It becomes a new regular expression now. There is a language associated with this. It is called LR star. Now, what about R? R is also a regular expression, and it indicates a language called LR. Now, these principles can be applied to form any complex regular expression that is required in our pattern matching exercises. We have mentioned about operators in regular expressions, 3 operators. And out of these 3 operators, unary operator star has the highest precedence, and it is left associative also. Associativity is also a major concern in the evaluation of expressions. After star, concatenation is a next precedence. It assumes a next precedence, and this OR operator has got the lowest precedence. Let us see this expression. A followed by B star, then C. We can see that here B star and C are enclosed further in another parenthesis. Here, even without parenthesis, we can dictate or we can rewrite these expressions, because if we see this expression, we can see that it is formed as per these basic definitions. We have three operators here, and we mentioned that star has the highest precedence. So naturally here B star assumes higher precedence. So this parenthesis can be taken away from here. Now after star, concatenation will be taken up. So if you remove this parenthesis immediately around B, it will become B star followed by parenthesis, then C. As per the second rule, even this can be avoided, this set of parentheses, because BC will take precedence over B star, C will be taking precedence over this bar OR operator. And since OR operator has the lowest precedence, even the parenthesis around A can also be removed.